Hello, good day, everybody, and thank you so much for being here today. This is Nadine Alamy from the Taylor Geospatial Institute, but first I'd like to thank Connect Me, Rendered AI, and my dear friend Chris Andrews for inviting me to moderate this panel on adopting artificial intelligence, AI, data quality, and innovative training strategies in government applications. Before we start the program, I'd like to first thank you again for being here. And I'd like you to think a little bit about why you're here today and what you really want to get out of this webinar. I'll start. For me, I'm now leading this brand new geospatial research institute, the Taylor Geospatial Institute out of St. Louis, Missouri. And we are trying to spark this revolution in all things geospatial research innovations. And as the new inaugural director, I'm putting together the plans for geospatial science in agriculture, in health, in national security, climate, you name it. Can you guess what topic keeps bubbling up to the top of the list of priorities? What topic is cross-cutting all these applications of geospatial science in all these domains and more? Can you guess? Yes, you guessed it right. It's AI. And that's why I'm here. I'm here to learn from the experts about AI, about innovative training strategies, about synthetic data, about data quality assessment framework, and more. So that's me, but I would love to learn more about you. So maybe you can tell me in this poll right now who you are so that we can try as much as we can to cater the content to, who you are. Are you local state government? Where are you located? Let us know. So while you fill out the poll, also about your areas of interest and the sectors you work in, I want to say again how grateful I am for the lineup that we have for this webinar. It's honestly one of the best lineups I've seen talking about artificial intelligence in government throughout, this geospatial adventure. So while you fill out your, polls, let me thank again our panelists. So we will start our journey with Dr. Daniela Moody. She's the Chief Technology Officer at Geosite. It's a company trying to change how the world interacts with spatial data. And Daniela will kick us off with AI advancements, adoptions, the landscape that's changing in the public sector. She'll be followed by Chris Andrews from Rendered AI, our sponsor. Chris is the CEO and head of product at Rendered. And Rendered is a business trying to be this driving force behind new types of data for faster and better decision making. So you'll hear about unlimited synthetic data for training, tuning, AI. Mark Bosch, Computer Vision Science Director and Managing Partner at Accenture Federal Services, they don't need an introduction, will bring us back, and Mark will focus on one of the major challenges in AI machine learning. You guessed it, quality of the training data. So he'll cover an assessment for computer vision and model training. So I see Daniela is on the stage, ready to go. I want to remind you that we are all here for you. So any questions, clarifications you need throughout the webinar, please use the Q&A, which, we will get to as many of your questions at the end. It's the best part This is your opportunity to hear from our amazing experts, so please take advantage of it. With that, Daniela, do you want to kick us off?
Sure do. Thank you, Nadine. And thanks again, Chris and Render AI for having us at the webinar. Hopefully everybody can see my screen. There we go. So why am I starting on this lineup? Is, as you've seen, it really is about AI adoption in public sector. And you'll hear from my amazing colleagues what I would call more upstream type integration. I wanted to talk to you in particular about what I've seen around the topic of AI and AI adoption as it pertains to both the public sector and government, as well as some of the similarities when it comes to industry, especially in the area I call the situational awareness. That's been the one driving force that I've experienced in my career as a commonality between government and commercial markets. And so with that in mind, I wanted to give you a little bit of a blurb on why Geosite is so passionate about advancing AI and geospatial AI in particular, and why are we talking about insurance in this case as a connector to, I want to say, disaster response, natural catastrophic event response, and how it might impact some of the other adoption methodology across different sectors. A little bit about me and why I'm again, what made me today. I've had a very circuitous journey, I'm going to say, through my career. I started off with a PhD in electrical engineering from University of Maryland, College Park. This is my fourth startup at Geosite. But I've spent a little bit of time going from national laboratory type of research at Los Alamos, where it was very, very focused on developing AI and machine learning algorithms for that lived at the intersection of multimodal type sensors, both imagery and non-imaging modes. Spent over 3 years at Descartes Labs, very, very focused. It was one of the early company startups that began the effort into pushing at scale geospatial analytics and that geospatial intelligence from massive amounts of satellite imagery and other types of data. Moved then to Ursa Space Systems, did a lot more around SAR analytics and defense. And then prior to being a Geosite, I spent a little over a year at Arturo, literally developing AI models, and by that I mean deep learning models to extract information, specific information from high-resolution aerial imagery for insurance. And what I found through my journey is, first of all, when you actually meet a customer problem that is solvable with the things you've learned, namely geospatial and AI, it is absolutely addictive, and it's been something that's been now shaping my career. And I've heard many times throughout my career that AI in general has been a solution in search of or a hammer in search of a nail. I do believe that the time is changing to the point where AI technology is maturing rapidly, and that technology readiness needs to slowly start matching the adoption readiness in various industries. So today I wanted to walk you through how we've approached this adoption problem of AI, the broader scope of AI at Geosite. And one of the things that I wanted to bring up is we actually work in defense and in insurance as well. I'm not going to talk about what we do for defense today, but we are the sole source provider for an Air Force search and rescue coordination mission management tool. It has been fascinating to be able to bring spatial data and a rapid response problem to the Air Force. But for us, the journey started with the why. And I'm quoting here one of my colleagues in the industry, Nigel Walsh. He's at Google. But we believe that in the insurance industry, we've seen the greatest adoption readiness for geospatial and AI data at scale. And because that readiness is there and that openness to try new things and not let the adoption pace flounder because of challenges still in the technical adoption of AI, we believe that has been a market worth focusing for us. So before I dive into the next broader conversation, I wanted to bring up a poll that I crafted for the audience. And one of the things that we've seen with our direct customers in insurance has been the broader topic of AI has been maybe misunderstood. It just seemed like a black box. We've heard many different type of comments around what are the biggest challenges? And it's not always that the technology isn't ready. It seemed like a lot of the challenges were around the integration ability, or the ability to immediately use and create value from the technology in a way that mattered to that customer. So it did shape the way we approach then our posture in the market and how we now look at AI technology. And it is, I'm going to say it's a set of values that I know I share with my friend Chris, who's also on the call, which is you lead with your customer and product has to come first. And you do that by delivering value. So while you guys go through and respond to your to this particular poll, I wanted to go through a little bit why we feel that there was such a big challenge here. So we have a substantial amount of AI technology being developed, especially last year. We've seen a substantial jump in interest and adoption around the topic of Gen AI. It's become to such an extent a buzzword that it's left a lot of I want to say, the practitioners of AI, sometimes perhaps a little bit puzzled or trying to keep up with the demand because, to make it quite easy, my 10-year-old son can probably get on ChatGPT right now and come up with something really crafty that is borderline a potential product that I might want to sell to a customer. It doesn't mean that he's done it correctly. It doesn't mean that it is something that's validated and vetted and that has gone through the rigor of data training and testing and validation and basically has that ethics background into AI. So I don't know if the poll is still running, but be curious to see those results when we have a chance, Leah. So we see a pretty even split. But what's interesting, and I assumed as much when I made those questions, to a large degree, what we've had in our early engagements with our customers, it was not clear how exactly the buzzword and the excitement and the hype around AI actually meets the need. And so what we set out to do in our practice and penetration, I'm going to say in the insurance market, has been to actually hone in on that, right? It's not the only problem. I think after you pass that, hey, you found a way that AI technology can meet your need. There are other issues that have to be addressed, right, around security and integration and compliance and all sorts of details that I'll go over a little bit. But AI technology, remember, it is today we cover but like 5% of perhaps what I would consider AI. There is so much that can be considered AI, and just the way the particular way in which you want to adopt AI type technology will change drastically depending on your industry. So why the insurance industry will be first to reach widespread adoption? I said we wanted to start with the why. We start with the customer and the customer need. They are, and we see this, like I said, around the state, local governments as well. When it comes to insurance, they're at the forefront of fighting or addressing, if you will, and responding to impacts that revolve around the climate security, climate resilience problem that we are facing as a planet. In all of this, they are looking at increasing and improving their customer experience. So when they look at a product and an AI, they do not want necessarily, or they want to trust that the model or the particular insight or the analytic that is being provided has been done well, and there are metrics around it, and the training data to support it is what it is. But at the end of the day, they care about actionable insights at the location that they care about the most. So with that in mind, we ended up looking closer at the what. What is it that we have to do? So I have here 4 categories that we generally have seen as relevant to the insurance market. Imagery, I'm bidding in the vast volume of everything that could be aerial, terrestrial, drone imaging, including SAR imaging. But geospatial AI, this has been actually developed quite heavily over the past 4 or 5 years, especially when it comes to individual models. Think here object detection, but applied to rooftops, to properties, to trees, and so forth. And I know you'll hear a lot more about that from both Chris and Mark. Extremely valuable insights that have been derived by InsurTechs. What we found is that geospatial AI in this context is not sufficient, right? You have to create a comprehensive map of that situational awareness by also adding things like models, climate adjusted models, other geospatial analytics. Think your vector and raster data sets that can give you the insights you need at a particular location, as well as other types of bulk data sets, column IoT, parcel governance data. For example, things like particular states deal with policy and insurance and boundaries and jurisdictions very, very differently. All of that has to be considered when you look at this data in an aggregated fashion. Geospatial AI, the general topic of generative AI and what AI can do for you will actually cross all of these four categories of data, in that I believe what the future holds for a lot of the public sector and these high rate of adoption industries like insurance is moving and starting to evolve the context of the contextual AI. And what I mean by that is, that human interpretation of four data sets brought together, what do they mean to you? So with this what, I wanted to give also a visual on what types of data you look in. This is not, by no means comprehensive. There's just a lot that we can cover. But for our customers, it is very important to consider more than one types of data set. So there's coverage, there's timeliness, there's the modalities, the model accuracies. Let's make a specific example about model accuracy. A lot of the examples that we look at in an insurance fashion are what you would consider rare targets. I may not have sufficient training data to properly determine or define damage when it comes to hail on a roof, but sure, I would like to try, because the faster I can make a decision and validate that data, the happier my customer is. So you'll hear more about this. There's obviously a room in this for, training things correctly, using synthetic data, leveraging the little real data that you may have. And throughout all, what we've built has been an experience that let you not just create a model that's, I'm going to say, vertical or sole modality, but think of this multimodal type validation where it's a different types of customer validation, when you can say that the model that predicted the hail damage is actually consistent with what the claim was on that property, right? So there's a little bit of that feedback loop that is very, very valuable in developing such models in the insurance side. So the need has been matching. I put here a lot of data because it's been impossible to quantify. We're looking at exponential growth. We have many partners looking at hyperspectral, multispectral launches, more SAR. The risk landscape is changing. And in case you guys are not aware, insurance markets are very, very risk averse. So they want to understand holistically what happens to their property, what happens to their risk. And it's not that they don't insure if there is risk, they just want to quantify that risk. So what we deliver with that in mind has been a product experience rather than a technology. These are just some examples of what we deliver. And I wanted to give you a hint of an accidental product that our team had to develop, because we had to create this, even validating the location where you look matters a lot, right? So in this particular case, hopefully you guys can see my cursor. There's the two panels on the top. That is a property that was incorrectly placed by the insurance in the middle of that berm or road. This was a particular case of a flooding event where, had they looked at that location, not only would they have gotten wrong data, but also would have not shown that the property was actually severely flooded by that. So this is that impact of correlating geospatial, spatial accuracy, and I'm going to say practices and rigorous practices of geospatial science, AI science, in such a way that the science part of it is obstructed in a way to the customer, and they can just know and start trusting the data and get that immediate impact right away. So we do this for over 1,000 different attributes from many, many different data partners. This is no small feat. But what we've seen is that, so think your data partners, every one of these individual 1,000 attributes may be model outputs that have been trained separately by X type of companies. The power of this is that everything is in one place and can bring that immediate insight to the customer. So as a case study, to get in that relevant answer quickly, seamlessly to the customer, Hurricane Ian is one that came up. This was a massive undertaking for both the federal side and the private insurance side. But with this type of geospatial data and automated models, we're able to get, quickly before, think of it as a situation awareness before, as the event happens, get more and more data in. All of these models and all of these inputs from our partners are integrated automatically, so that a week out, the insurance is already able to make decisions, and in some cases meet their customers where they need them the most without having to wait for somebody to go in the field and do all these things, right? They have all of this at their fingertip. I'm going to skip this particular slide, but just to give you an idea, same thing, right? These may be very complex models to get flood depth. They don't care about that. They just care that at that location, the flood depth maximum was that. So it's that, how we were able to do this and why I'm so passionate about the adoption of AI is you have to start with that focus on the value to the customer. In order to really realize, I think, the true potential of AI and geospatial AI, we have to make sure that we deliver that product experience, not just the technology, and you optimize it so that it addresses an industry level need, right? Not just a sole project or pilot. And it's easy to integrate, right? I wanted to make it so easy that my son could use it if he could, and make it intuitive so that it is actually streamlined based not on the, how cool the AI tech necessarily is, but what is the established human workflow, right? Because at the end of the day, we do believe, this is part of our tenets, is that AI technology is here to stay and is here to augment and expedite our workflows, not to replace our jobs. We are seeing that extreme passion for adoption of AI in insurance. They absolutely see this as a, increase of their revenue and their throughput. So they're very excited. But again, what we've seen with this is that just because the technology is ready does not mean that the industry is equally ready to adopt. So we've built this product so that we can build it securely, so that we can integrate with their existing system. We're not trying to change everything, but just trying to make it easy for them to use this data in a way that delights them and in a way that makes that impact immediately visible to them. So I'm going to stop here. Would love to hear more from you guys during the questions, but with that, I wanted to pass the baton to my friend and colleague, Chris Andrews from Render AI, and let him take it from here.
All right. Thank you very much, Daniela. Let's see. I just need to find the button. Sure. All right. Thanks a ton, Daniela. That was really great intro to what I'm going to talk about. And then Mark and Nadine, thank you so much as well. I really want to thank all three of my colleagues for participating today. It's super fun to be able to talk to this group. Some folks on the call might know me from my past experience. I've been in geospatial for about 25 years, and most of that has been actually in local government and state government work, and a lot around AEC. I started out as a product developer, went into enterprise consulting, and then ended up at Autodesk for a while, and then Esri for a while. I joined a small company called Rendered AI about 3 years ago. We're about 5 years old, and we focus on something that a lot of people haven't even really thought about, which is helping customers create data from scratch when they may not be able to collect it or otherwise acquire it. And I'll go into that a little bit more in a bit. As you can see, that we are affiliated with a variety of groups who touch on local government, including folks like Esri, who is a partner, NVIDIA, RIT, and we also are affiliated with the Open Geospatial Consortium, and I'll talk a little bit more about that in a bit. We work across many different domains, some defense stuff, insurance, including residential type stuff, also like local government security applications. Go ahead and please run the poll. All right, so the poll that's coming up is going to ask you about basically what I'm going to discuss on this slide. So what we find is, and everybody who's going to be on the stage today is going to talk about something pretty critical, which is data. For AI, data is essentially the same thing as what programming code is to a video game. Without data, you can't get the analyses and outcomes that you're trying to achieve with algorithms. Essentially, what we do as AI-focused professionals is we take data sets, we run them through complicated algorithms, and then out of that algorithm comes something that might be called something like a detector that we can then take and apply to novel data sets to see if we can find or identify the things that we need. When we are using data, though, and I'm sure many of you are acquainted with these issues, we run into some pretty typical challenges. For one thing, data can be really expensive to acquire. So if you're trying to acquire like a new or rare type of satellite imagery, or you're trying to collect drone data for a large city, you have to budget for it. And then if when you budget for those things, you end up with a kind of a time limited, time defined, fixed scope project. And at the end of that project, you've spent your money. And then if you find out your data doesn't have what you needed, you're stuck. You're stuck with the data that you were handed. So data can be expensive to acquire and also time intensive, right? If you need to go back and reacquire data, that can take you in some cases months or even years. When you're trying to build algorithms to detect things, you often don't want to detect only all the common things. So often you want to also be sure that you're accurately detecting rare things. The inability to do that is often referred to as bias. And bias comes from the fact that often rare objects and scenarios are not present in data sets. Data labeling is a key part of training machine learning and artificial intelligence algorithms. When you have a data set that you're going to use to feed into this algorithm, you need to train it. You need to basically identify ahead of time all of the things that you're looking for that you're trying to classify. That's referred to as data labeling. And data labeling, whether done by humans or machines today, is typically inaccurate, which can lead to problems in training. And then, of course, if you're talking about a sensor that hasn't even been deployed in the field yet, well, you want to start. There's a question in the chat that we'll address later about how to demonstrate that AI is useful. When you are trying to deploy a new sensor, you often can't, because you can't prove that it's going to be useful, because you can't get data until after you've actually deployed the sensor. And so customers often find that they can't innovate when they're trying to think about building algorithms for a future sensor type. It looks like for me, the poll is still open, and I'm going to go ahead and move forward. All right, looks great. All right, thanks for filling that out. So one of the approaches to addressing the kind of the data gap or the data problems that I just talked about is actually to create data. And that's a novel idea, even though it's been around for a little while, but it still is a novel idea to most data scientists or GIS analysts who typically are just handed a data set and told to do something with it. What we are actually all about is helping customers create data that they can then use to train algorithms. And sometimes that's to completely train an algorithm based upon this thing called synthetic data. Other times it may be to supplement a real data set with unusual cases or rare events, or even arbitrary test cases, in some cases to see if you can make an algorithm fail. Synthetic data is engineered data that basically AI interprets as real data. We often talk about physically accurate synthetic data, meaning that we're modeling the distribution of values in the pixels that are in imagery to represent real, to basically simulate what would be collected in real imagery. And as you can see from some of the quotes, it's not necessarily a brand new idea, and it is definitely something that many people in the AI world think is going to be a major component to training algorithms into the future. Okay. I think all of us out there have heard of Fortnite, and we've seen 3D games even on our phone, and now of course there's all this talk in the news about the Vision Pro and 3D and all these great technologies that are fun for film and game and entertainment. Many folks think that they can essentially take one of those game engines or simulators, use it to generate a bunch of images of some target data set that they're interested in, and then train an AI model and go away from there. What we've seen is that pattern for generating synthetic data simply doesn't work. Often customers will pay somebody else to build a synthetic data set. They'll get what they asked for, but they didn't really know what they wanted to ask for at the start of that project. Because remember, I said that that many data scientists are handed data sets. So they're not used to even thinking about, well, what would be in the ideal data set that I need to train my algorithm? And at the end of that project, they're again stuck with the data that they paid for, and they kind of get what they get. What we have seen is that the use of synthetic data, like many types of data, requires an iterative workflow. In the case of synthetic data, that workflow starts out with somebody defining what they think is an ideal data set, and then having this role that we often call the synthetic data engineer use 3D tools, 2D tools, simulators to basically create what we call a synthetic data channel to basically simulate the type of imagery that the customer wants. The customer then needs someplace to deploy that simulation, because they're going to run it 10,000 times, 100,000 times. That is not a typical workflow that you get with game engines. So you need a specific tool to help do that. And then at the end of the day, you're going to hand that data to data scientists who need to do things with the data. They need to run training on it. They need to test it. And they may actually need to communicate back to the synthetic data engineer that they need some changes because the data set's not quite right, and then rerun more simulations. And those simulations, when it comes to synthetic data, will be spit out with 100% accurate labels. But again, it's a process that requires some thinking and trial and error to figure out if what I'm generating in my data set is what I really need to train my algorithm. That iterative process is the only way that we've seen successful application of synthetic data in computer vision training. So rendered basically provides two components. We have a platform as a service that runs in Amazon Cloud, and that has a variety of components for deploying a simulation to the cloud, creating data sets, including through a fairly simplistic web-based drag and drop interface. We have some tools for post-processing data sets, so we actually can take real data sets and make synthetic data sets look a little bit more like real data sets through some of those tools. And then we have APIs and SDKs for integrating into ML pipelines. On top of that platform is actually like the customer value that is kind of created, packaged in these simulations. So you can see we've got examples of everything from apples to synthetic aperture radar, X-ray, all kinds of different things. And each of those applications is called a synthetic data channel. We provide an open source framework for packaging those channels and then deploying them to rendered. And then a data scientist can actually sit at our interface and configure data sets to their heart's content and run them over and over and over. There, we have some great proof points. One of the first big projects that we did was with the NGA and Orbital Insight. The Defense Department tends to be the first investor in a lot of new technology spaces, as everybody on this call likely knows. Orbital Insight was presented with the problem that in a lot of nadir imagery, it is really hard to identify unusual objects like construction cranes and tower trucks and things like that. And so labeling tends to be really inaccurate for those things. So what we were able to do is work with Orbital to generate literally tens of thousands of synthetic data images with examples, with fully labeled examples of these objects. We were able to test out some post-processing techniques to actually make synthetic imagery look identical to real imagery. And then we were actually able to show that with examples that had only 100 cases of each class that we were looking for, that synthetic data was able to substantially improve detection ability. So if you think about things like construction cranes, it's super useful to look back through an imagery library and identify where all the construction cranes were, so that you can see what economic activity was happening in a city around construction. And this application of synthetic data is one of the better ways to be able to identify unusual objects like that are really hard for humans and machines to otherwise detect. In this case, it's not just about generating the data and then running it through an algorithm and seeing if it works. We also try to build out some tools to help make data sets more explainable. This simple video here shows one of those tools that we've adapted into our platform called UMAP. And in a simplistic way, UMAP basically takes all the pixel values in your imagery and reduces those to points in an imaginary 3D space. And you can use a graph of those points to show how similar data sets are. And so what you see here are the green data set is the synthetic data that was created by auto-rendered by the Orbital Insight team. The blue data set is actually the original source, kind of real data set that was going to be used for validation and detection. And then the orange data set is actually the synthetic data set, but post-processed through an algorithm that basically makes it have more similar pixel values to the real data. And what we were able to show with this is that by doing that post-processing, we actually could explain why the algorithms actually ended up with better performance than without the post-processing. And so making AI more explainable, making data sets more explainable is a big part of what we're about as well. For the UK's Defence Sciences Technology Lab, we supported a company called Faculty who basically had this problem where DSTL wanted them to prove that they could train algorithms on a data set that they didn't yet have. And so Faculty was able to do exactly that. They got up and going in just about a week. They were able to generate a whole bunch of data sets to their heart's content. And they were able to demonstrate that they could find the things that DSTL would need to find in the future. Interestingly, they also did things like without even consulting us, like colored all of the objects they were looking for yellow to prove that their algorithm would not actually detect the objects in that case. So they actually used synthetic data to create absurd imagery that basically should fail in predictable ways. And one of the most amusing things we heard was that Francis Heritage, the primary contact on the customer, he was frustrated that his data scientists kept using the rendered interface because it was easy to use, but also because data scientists, like I said, don't typically get to make their own data sets. And with synthetic data, they can. We also supported Planet. Planet, as you all know, has been out there collecting imagery of the Earth every day, everywhere on the Earth for many years now. They're putting up a new satellite constellation in timer. They're putting up a new satellite constellation focused on hyperspectral imagery. We were able to work with the RIT DEERS lab and their technology DeerSig to provide them a simulator of their future hyperspectral constellation. And they were able to use it to prove that they could do things like detect methane plumes in future types of hyperspectral imagery. And then they also were able to use synthetic data to prove out their AI pipeline before they even started collecting imagery. And as I mentioned, we also worked with Nadine's former organization, the Open Geospatial Consortium, to use synthetic data to test out two different aspects of a recent testbed project. One was that you could use synthetic data in a process called transfer learning, which is essentially taking an existing algorithm and then tuning it for a specific data set. And we were able to show that was possible with just synthetic data, which is a great innovation because typically transfer learning today would require that you go collect a whole new data set, which could be costly and difficult to label, et cetera. But with synthetic data, that provides you some opportunity to tune algorithms more efficiently. And then we also were able to demonstrate that synthetic data can actually be used to kind of generate idealized data sets so that you can use them to basically build out pipelines that will anticipate or expect and be able to validate that you're receiving certain types of data that you know you're going to receive in the future. This is referred to, in this case, as analysis-ready data. It was a fun set of projects to participate in. As I said, we work across a whole bunch of domains, everything from residential insurance to hospital patient monitoring to security in imaging for things like weapons and backpack scanners. And we don't do all that stuff, our customers do. We help them package their own simulations and run them in our platform to generate data sets to train algorithms. And so a lot of you folks might be encountering new types of imagery like hyperspectral and multispectral. And I suspect you're going to see a lot more synthetic data used to train algorithms to help you detect things in those types of imagery. All right, so the way that we sum it up is basically to say that tomorrow's AI workflow incorporates synthetic data. We already see that happening today. It's definitely happening in the big folks like the big autonomous vehicle companies and the Defense Department. And Rendered is all about helping everyone access synthetic data to help train algorithms. Synthetic data is inexpensive. It can be unlimited. You can generate as much as you want. It's 100% accurately labeled. Real data sets can still be used when you're working with synthetic data, and data can be designed for edge or impossible cases that you're never going to collect in real imagery. So thank you very much for listening to me for a few minutes, and I am going to turn it over to Mark.
Okay. Well, my name is Mark Bosk. I'm a computer vision lead at Accenture Federal. My team does quite a bit of computer vision, so we're always battling with data quality, with the fidelity of the models, ultimate performance. And so I wanted to kind of capture a little bit the perspective of a practitioner doing AI, so sort of some of the hurdles and how we address some of that by looking at the data, the quality of the data, because ultimately that has a great impact in how the AI performs in general. So as you can see, my team works on several aspects of AI computer vision applications across the board, geospatial, which is the recurrent theme today, but also in other types of imagery, all the use cases. Ultimately, the challenges when it comes down to models or building models for AI remain the same. The data possibly carries 90% of the success or failure of a model to be able to meet requirements or just fall short of them. And so we're always trying to maximize the data that we have, try to be smart about how do we select the data that we're going to use for model training, but also for model testing as well, right? And so ultimately, there's a part of the process that involves really going down and understanding the data, right? And so before I go into some of the strategies that we use, I do want to just level set on kind of what the problem is ultimately that we're asking AI to solve, right? And so when you look at these pictures on the screen, as a human, you can tell these are 4 versions of the same building, right? Like you can spend more or less time in some of them, but ultimately you'll come up with that decision. And I did not have to show you those images beforehand, right? You came up with that conclusion yourselves. AI today cannot do this unless we've shown many examples of these specific types of images. And so that's a problem, right? Because the starting point from computers is a much lower than with humans, particularly on visual based problems, right? If we were talking about language is a different thing, and that's possibly why you've seen like such an advance in large language models and what AI can do today on text and language representations. Like images and videos do not carry that. Like there's no semantics attached to a pixel. There are semantics attached to a word. So the starting point is more behind, right? And so when you add also the fact that AI tends to learn by memorizing, by seeing many examples, and you also add the fact that there is no data theory. Like this is one of the few fields that there's no theory itself. There's no theorem that I can go and say, all right, if I collect these 10 images, my or this type of imagery, my performance will go up or down, right? Like there's no such thing. So it's a lot of trial and error. It feels like alchemy many times, and so that is a problem, right? As a scientist, as someone that's trying to build this, but also as a stakeholder of I want to use AI, right? Like I need to rely on AI, but today the technology for certain applications, it's not mature, or you have to like really spend or make a large investment in it, right? So data, as I said, data still is the big hurdle, and for models, you have to be aware of how they work or how they do not work to be conscious on what is the data going to give, right? Like Chris was talking about, like synthetic data needs to represent like, like the physics of the world, right? And maybe like the AI itself will not learn how the world works according to the physics laws that we have, but it will know that physics affect the appearance of objects in an image. And so that's what matters, right? Like being able to capture that appearance so that the models can learn. In a typical computer vision, and that I can extend it to any AI application, really like the development workflow looks like this, right? You have some sensors that collect the data, you have a data set somewhere with most likely labels that some experts have annotated or not so experts, and then you start feeding that data through your model. Typically the model will have an ingestion layer to like process the data. It'll have some what's known as a base model. It's something that's been trained with large amounts of data to sort of have a general knowledge of what the world or the data looks like, or get some initial statistical distribution of what general data looks like in that domain. And then you'll have like a specialized component for your specific task, right? And whether I'm trying to detect roofs from an overhead image, or like figure out where the roads are, that might change what the specific part of that network will look like. But ultimately the architecture is rather stable and similar. And so the first thing that we want to do is we need to understand what the data looks like, right? You have, as I said, large collections of images or videos or other types of data, and we tend to like feed that into the network as a black box and just measure the output, and that's like the standard traditional way of doing development. But if you skip the step of understanding what my data looks like, you will miss a lot of opportunities, and you will miss a large percentage of your source of errors, or why your models are not reaching those requirements, right? Because you did not possibly spend enough time understanding what is the data that I have to work with. And so one of the things that matters is if you are, for instance, and I was saying in one of the previous polls, right? Like one of the issues is that like the data that is annotated, it's noisy, it has flaws, it's inaccurate, or it's missing information, right? And so one of the things that we've been working is, how do you have, and ideally when you're doing an annotation exercise, if you have the possibility, you want to have multiple humans looking into the same set of or subset of data, right? So you want to have overlap across humans so that you can kind of take like the majority, what the majority is saying, or how the majorities are annotating, or an average, or something along those lines, right? And so it becomes a problem when you're not necessarily like tracking how that data is being annotated. So one of the things that we looked at is we tried to see if we can measure the quality of the data from the annotations, from the annotators. So like the annotated data, right? And so we found ways of making a computational model that is basically measuring the level of inter-annotator agreement. So how much the annotators are agreeing on a specific sample, right? And you will give them instructions, this is what you look for, or if they're experts, you just hope that I guess they know their field, right? But still there's inconsistencies, right? And so we build this tool so that we can measure the level of consistency across annotators as a way of selecting or being able to flag annotators that they're possibly not agreeing with the majority. Maybe they're not necessarily understood what the problem was, what the task was, and so like gives you opportunities to like retrain some of these annotators, right? Again, the goal is to like improve the quality. And so one of the things that we saw was that when you have like these tools, you can actually just take the tools themselves, and if you don't have the ability of going back and ask for re-annotations, you can still use those formulas or those numeric representations and make decisions on, okay, I'm going to use this part of the data set. I'm not going to use this part of the data set because this annotator specifically, or this group of annotators were not consistent. So it's going to add the kind of noise that I don't want in my data set, because that's misinformation. And you're starting to see how the models improve. And so, for instance, in this table, what I'm showing you is how a model, without adding more data, without going back and annotating, by you having a strategy of selecting what data am I going to use for my training set based on who annotated that data and their level of agreement with the majority, how I can improve my models substantially, right? When you've been working in this in a problem for a while with the AI, at some point you're going to saturate the performance, and every next 1%, it's very hard to get. And so it was our surprise when we started to see these numbers change dramatically with the same data, just by understanding what data do I use or I can use to train a model, right? So that's definitely one of the practices that we've been using, and it's always been something that we have in our back pocket to improve the models when the data is frozen, when the algorithms are also frozen. We still have the ability of doing that. And you'll say, yeah, but this is only within the context of you're doing an annotation exercise. You have individuals looking at the data. And it's not necessarily true. You can do this with algorithms, right? You can say, I'm going to have, a model solving task X, but I'm going to also have 5 variants of that model that I'm going to change slightly the architecture. I'm going to randomly remove some of the parameters, or I'm going to make some permutations of them. I'm still going to train them across for the same task, and then I'm going to apply the same agreement or the same measures that I used before, that I showed before, to see how the models are agreeing on targets. And that is going to help you detect what version of the model are improving or are better performing. It's also going to show you how some of these data, because each of these models can be trained with randomizations of the same data set, how that data affects that specific model, right? So by being able to measure the agreement, either the annotators or algorithms trained onto a specific task, you're able to quickly understand and identify gaps in your data and flaws in your model, right? So that is something that we use it as a practice to improve the models as we develop some of these algorithms, right? So that if you go back to that initial baseline model architecture that I showed, if you add these components where you're starting to generate and train versions of that model with the same data and obtain permutations basically of the performance, and add these kind of agreement measures, you're able to accomplish that, right? So that's one of my suggestions, right? To start spending time in building permutations of your models to see how they are all agreeing, whether there's a possibility that the data might be improved at some point. The other thing, and this is something that Chris was also showing for the synthetic case, is also understanding that data distribution how it's distributed in the space that the AI looks at it, right? I can show you pictures and pixels, but that's not what the AI looks at to make the decisions, right? It'll extract some patterns out of that image, and it'll use that vector that kind of summarizes patterns, and it'll use that to decide whether there's a building in that part of the image or something else, right? So when you look at the distribution of your data in that space, you're starting to see very interesting things, right? So what I'm showing here is I just take my data set, I pass it through one of these foundation models that has been trained with a lot of data, and it kind of has a general sense of how the data is sort of represented visually, and I plot that, or I project that into sort of this embedding space, so that each of these dots that you see there, it's an image, right? And they're colored depending on what the label during an annotation was. And so what I can do is, I can, instead of projecting I can project the images instead of just dots, right? And you're starting to see that the actual data distributed, and you're starting to realize that, okay, I have gaps in my data, right? It's if my test data, if where I'm deploying this algorithm produces data that its embeddings fall in the far from where I have data, then I'm going to have a problem, because the algorithm that's where mistakes can happen, right? Like that's where inaccuracies in models happen. So one of the things that we can do in this case is, once you have identified these gaps, you can pick anchor points that you do have images available, and you can take those embeddings that were basically used to create these projections, and you can interpolate them. You can do averages. You can create a new embedding that came out of the original data that you have. And you can send that to a model that is one of these stable diffusion models, for example, that just generates data, right? And you can have models that out of noise, they generate new data, out of text prompts, they generate new data, but you can have them also being guided by embeddings that say, based on this embedding, generate me an image that would end up into, like, it would fall into get projected into that embedding, right? And so you can see here, like an example, right? Like we generate an image out of 2 images that we do have to sort of be able to like fill the gaps a little bit in my data set, right? So that's another important strategy, that when you don't have the ability to like, again, collect more data and you're stuck with the data set that you have, you can still produce data that is reasonable, that falls under the distribution and is able to like cover the gaps by applying strategies like this, right? And so when you have your entire pipeline, it kind of looks like something like this. Then the third piece that I do want to mention is the goal of generalization, right? Like ultimately, what you want to do with the data is generalize and make it work in as many use cases you have, in as many environments, domains as you need to. And so obviously the easy answer is, well, I'm just going to try to collect examples from everywhere, but that's not feasible, and that's where, again, cost comes in again into the picture. So there are strategies that you can use to like augment the data, right? And so you can augment the data the way I was kind of showing you before. You can have a way of generating or what's called domain adaptation, that you can have your AI models kind of forced into produce out of one data set, kind of produce embeddings that are similar from a different data set. But what you can do also explicitly with the data is transform what's called a sensor adaptation, right? Like, can I transform the data to look like more as if these other sensors have taken it? Because the reality is that, and you know, everybody that works on AI knows that the moment if you train only with images or data that was acquired with one sensor, and you try to reproduce that onto a different sensor, things are going to fall apart. If you try to train with a model from one satellite, and you apply that model into a UAV video, that's going to fall apart in a large probability, right? So what can you do to like make sure that you can adapt some of those images to your test case, right? So this is like the area of domain adaptation. And here are like some examples, right? Like, there are models that can transform your input into an output that it's going to make it look like as the test sensor. And so what I'm showing here is some experiments that we've done for different use cases, right? Like the super resolution at the bottom is, I have a sensor that kind of produces this type of objects of the scene at that resolution. I can train a model to like super resolve or make it look like as if a higher resolution or a lower altitude, for instance, sensor had acquired that image, right? And we show that when you do these things and you train in task model that it's trying to find planes or whatever it is, when you train explicitly with this type of imagery, it'll be a much easier problem. And the same with sensors of different like characteristics and appearances, right? Like, you can have a sensor that produces images like this on the top, and you're trying to make it work like the model with a sensor that's going to produce images like this. So what can you do? You can transfer the style, the characteristics of that sensor to the model, so that ultimately the model can actually show improve ultimately on the task that it has to be, and for the sensor that it has to be deployed. So when you kind of put all of these things together, right, from that initial model that I was showing, by being able to measure the quality of your data, by understanding the quality of the data, and by you proactively like trying to get creative in a way in the usage of the data or in the selection of the data, you're starting to have a model that kind of looks like more like this, right? When you add the training stages and things like that. And sometimes while you would imagine that those are like yeah, that those are common sense practices that you should be doing, right? If I want to have an AI that works, you know, ultimately that's not reality. And reality is going back to that original model and trying to use as much of the data that I am able to leverage and make the most out of that. But ultimately, that will always give you like suboptimal results, right? And you have to figure out a way during development to prioritize the understanding of the data, the value of the data, the curation of the data, and you know, the synthesis of the data, so that it's actually the added value that you bring to the data will translate into an added value in performance for your model. And so that's all I had for today. And so what I'll do is I'll invite back. I think we have the Q&A session now, so I'll invite the rest of the panelists to join me. But thank you for your time.
That was fantastic. Thank you. Thank you, Daniela. Thank you, Chris. Thank you, Mark. And thank you, everybody on the line. So this is your chance. We have about half an hour for you to ask all the questions you want. So I'm going to whet people's appetites a little bit. You know, Mark, it was an amazing presentation, especially following what Chris had just presented. So Chris, I went back to your poll and I noticed, so you asked, what challenges do you have when applying computer vision? And this was before Mark, shared his experience. And you had more than 50% of our attendees, which are like in the hundreds, saying that the main challenge is data sets are frequently incomplete or have inconsistent labels. And I want to hear your thought about whether, for instance, now after hearing Mark, after hearing about synthetic data, if we ran a similar poll, would we get different results? Because maybe part of what's missing is, you know, people don't know how to complete their data or how to be more consistent. Just want to hear your thoughts, Mark, Chris. Thank you.
For me, I'm
yes.
I'm not surprised that, like, as I said, you know, one of the most fascinating things that I've encountered and observed, and this also echoes some of what Daniela said about really paying attention to your customers and their needs. And data scientists today literally often just get dumped data sets. You know, hey, we paid for this data set 2 years ago. It cost $250,000. We have a small city budget. We just want you to go find all the swimming pools in it, or whatever it is, right? All the cracks in the roads. And so often data scientists are kind of at the point where they have to make something out of essentially nothing in many cases. And they do it, but that leads to a tremendous amount of uncertainty. And also what they'll find is, okay, they had to go do a ton of manual effort to label, you know, pick out a few swimming pools, for example, if it's just a data set that's sitting on a shelf, and kind of start from scratch. I'm really not surprised to see that's one of the biggest gaps for this audience. It's such a fundamental thing in the market, and it goes right back to this aspect of data science in which often people are just handed data and then told, make something from this. Daniela or Mark, do you guys have any other thoughts on that?
So can I actually, I think, Daniela, because I think this relates so much, because your poll, I think, Chris, it's like you queued it. Your poll, Daniela, had 26% of people saying that early adoption is too risky and complex and we'd like to wait. And I know you're passionate about the AI penetration. So I think this is directly related to, I think the observation that Chris just shared with us about data scientists and our mode of operations.
Yeah, I think a couple of the comments that I was getting ready to make too is, and thanks for putting that poll back up. What we've seen, at least I'm just going to speak to this one vertical, is there's a combination of the early adoption being too risky, and sometimes it is, like Chris said, right? There's a decision point. I saw there was a question earlier too, right? There are small city budgets or local budgets, and you have to make a decision about buying this data or investing in this model or this whatever, but that eats up your whole budget. So if you're not able to show that, hey, it had an impact, then you have a big problem, right? So that going back to the same stakeholder and say, well, the $250,000 we just spent on this data, I don't know how to tell you this, but we spent 6 months doing something and not much came out of it, right? And we spent a lot of effort, but all the swimming pools were already labeled. All we had to do is go dig up OSM data, and that would have been free. So what we're seeing is, maybe this is not going to be a popular answer, but I don't think there's a silver bullet anywhere, right? I think it will take a partnership and a combination of getting more and more familiar with the offering in the market and figuring out what is the need and what is that customer problem you're trying to solve. Because in some cases, our problems are more in the, edge cases, rare cases, how do we extend the value of a model beyond that underlying distribution that Mark was referring, that may be something that we've assumed, but nature has its ways, and there's always parts of that distribution that you may not easily absorb. Well, then I may need more synthetic data, right, to account for those edge cases. So I don't think there's a straight answer. I think there is just a really complex process to adopt or to have. It's not sufficient to be open to the AI technology that's emerging. You need to have the right hooks in place technically to enable that AI digital transformation within your organization. And I think the unfortunate bit with, I'm going to speak now as an engineer, we get so excited about the technology that we forget that, frankly, the customer sometimes probably doesn't care if I used, a YOLO model or an MCAR model. They just care about the final accuracy, right? So there is that trust that needs to be built with a entity that you're trying to get your product to, that, hey, I'm doing my part. I'm being rigorous. I can walk you through for the next 2 weeks through how I'm doing this. But at the end of the day, this one number is what you care about, and this is what I can deliver to you. So I think we're, probably a few years out from seeing more and more of the adoption that we've been dreaming of, but I think it's coming. I do not know if that answered your question, Nadine. So I think it's a very complicated question, I think.
It is. I think I appreciate you being realistic, because I think sometimes we all get caught in the hype and think it's simple when it's not. And so I appreciate you sharing the complexities behind, what we're really dreaming about. I like this. It's related to everybody. The issue of trust, and maybe we can touch on trust and a little bit of ethics. So we got a question from Shauna Rain Brown. So first, her example is about automated driving. So we've heard about insurance and defense and so on. So it's interesting to see automated driving as one example popping up here. And she had a question about the problems lying in the edge cases, and AI doesn't know how to show those edge cases. And so how do I trust? So maybe a quick comment eventually, because I think, Mark, you hit on this. It's about data quality. It's about, making sure we do our part. I love that part too. It's not just the AI, it's us putting actually the time in training and finding data sets. So any one of you care to comment about this question from Shauna on trust in the technology?
So I guess what I'll say is, this is an example that I use often, right? Like nobody questions the GPS technology, right? Like takes us from point A to point B. It works every single time. There's no debate, right? Like, so there's ultimately, like, I am a believer that if AI worked at the same level as a GPS, a lot of the trust would possibly disappear, right? Like I don't need, for instance, like there's a lot of people that don't need to understand how a GPS works to trust it, right? Like it just works every single time. And so there is a part that to me of that conversation that I would like to focus it on how do we improve AI, like the performance of AI, right? Like in a way that benefits everyone, right? Like GPS, you know, it doesn't really matter who you are; it'll route you the same way, right? And so like to me, priority one is get there with AI, right? Like can we get AI to work at that level for everybody? And then I think a lot of the trust disappears on its own. And so anyway, so that's kind of what I'm standing, right? Like let's prioritize on getting AI to really work how it should be or how we all expect it to work, and then let's see what's left of the trust conversation.
I'm gonna try to bring a slightly different perspective,
Yeah.
and that's you know, as a let's just say I've spent many years trying to develop AI models. I would love. I think the one time I got 100% accuracy on something I trained is because I accidentally looked at, you know, the test data being the same as the training data. So that was a fault on my part. I guess what I'm trying to get to is I do not know that it's realistic to expect AI to perform flawlessly. And what we define as flawless is a human behind the wheel, for example, right? We are the ones who are able to make those split decisions and have that ad edge awareness that I think the participant put out there to sort of immediately react and understand that edge case that I've never seen before, but I know how to make a decision about it. And I think AI, it's in inception, right? It's meant to create an artificial way of thinking that mimics the way our brain thinks. And our brain is just an amazing, you know, computer that does things that we've not been able to replicate in real life just yet, right? And I'm not sure that we, you know, want to get to that place where AI is 100% performant the way we want it to. I think I look at it more as a partner along the journey. Like the GPS case in particular, that is a physical measurement based on, you know, there's no training in the GPS, right? It's more, you make a calculation, there it is, right? And it has some error there, but I think what I found is to be most realistic and sort of not hinder that adoption is to be very, very upfront and educate the customer too on the limitations of the AI, right? Like I said, I think it's a journey, not just a destination. And that's what I'm not sure. I think that would end up building more trust along the way than you know, waiting till AI can deliver fully on its promise, which I still think we're a few years out. So not sure there's a clear-cut answer, but that's been my perspective. Chris, I think I interrupted. You were about to say something.
Yeah, yeah, no problem. You know, it's a great topic, and actually, the trust and access, affordability, those things are all related, and we're seeing quite a few of those kind of themes in the questions that have come in so far. One thing fundamentally that I'll say is, you know, there is no such thing as an unbiased data set, right? All data sets have some kind of bias in them. So if you're training these algorithms that are basically using or building up statistical probability to find something, you are always going to encounter the situation where a data set is never going to have something, for example, that you've never seen before. So like, you know, Tesla Cybertrucks are brand new. I guarantee you it's really tough to get a bunch of data sets with aerial imagery of cities with Tesla Cybertrucks all over the place. So data sets are inherently biased. They're kind of a corollary to some of what Daniela said, or related to what Daniela said. I don't think we'll ever get to a place where it would be possible to have 100% working AI, because we do not know the future, and that's just a fact of this technology. One of the things that I saw on Daniela's slide that really hit home for me was technology adoption is not the same. Technology readiness is not the same thing as adoption readiness. And so, like, a lot of the questions that we're seeing in the chat are about adoption readiness. And what this really reminds me of is the earlier days of GIS, and I'm sure Nadine sees this as well. What we used to see back then is a lot of argument over whether things like hand digitized parcel lines were going to truly be accurate, and debate over things like accuracy, and then working that accuracy into legislative requirements, so that you could have some kind of barrier again, or bar above or below which you could sue people or rely on GIS data. I think that the GIS ship has sailed. That's pretty well adopted across local government. And one of the ways that happened was through smaller local governments coming together and founding groups like DRCOG in the Denver region. So the Denver Regional Council of Governments, I used to work with them when I was in the Denver area. And what you can do is work with some agencies like that to basically pool resources and basically build test cases, so that you can start to test out things that you're seeing in other parts of the industry and start building up proof points. You typically do want imagery for larger than an area of just your city. Those kind of cogs are great for kind of coming together and pooling resources, acquiring data sets, and even sometimes setting up whole program teams to go and try something out. And that happened in the early days of GIS. I think we're much better structured, especially in the U.S. And I think most of our attendees are from the U.S. to accommodate those types of pooled resource groups. And so I'd say, look at this as an adoption readiness problem. The tech is coming along. You, just like the early days of GIS, you're going to have to work with your supervisors, governments, and even legislation changes at some point to adopt this new technology as it really comes into its own. But we constantly hear about computer vision and artificial intelligence, but I even have to remind folks that in broad parts of the industry, the pace of the technology has way outpaced the ability of our customers to adopt it, and I think that is a big problem in general.
Sounds great. So let me ask a follow-up question from Keith Deserspring. Because we're saying the technology is out there, it's the adoption, but in that case, because we have a lot of local government representatives here, so the accessibility of everything we're talking about, the tools, the platform, the data quality frameworks to small data science teams. So I think, Chris, you talked about the data science team for the STL. So I think it's a good question here, because most of, I take it from the GIS experience, they have very small GIS teams, if they have anything at all. So how can we help? Is this still, Daniela is talking about this journey. Does this journey include the little, teams as well? Any comments on the readiness for the small teams out there?
Yeah, I can jump in on that. I saw the comment around AWS SageMaker. So our platform also sits on AWS. AWS SageMaker is a particular, I think, capability that AWS has been rolling out slowly over the year. One of the reasons we don't directly use some of those features there, but I remember as I was looking at them, those were deployed out there by AWS following years of research and basically aggregating information around the needs from their various customers and partners. So I don't disagree with Keith's comment that maybe some things may appear bulky, but if it's a free resource that, for a small data science team where you could potentially get AWS credits or just get things GFI'd, it is a good way to at least start to play with some of those tools and see if you can leverage in a much cheaper way the open data sets that are on AWS. I know they put a capability in AWS SageMaker around Ground Truth Plus, I believe, to do labeling a little faster, or to apply, let's say you spend half a day developing a pool detection model. Could you run that pool detection model on the imagery they have available open source, and then use that as a pre-filtering to get yourself more data that you can label later? So I'm a firm believer where there's a will, there is a way. I think some of those tools are, they're definitely available. Not all of them will be cheap. I think a lot of them will be determined. I think it's important to determine first, what do you actually need, right? If the driving force from the leadership is must integrate AI in what we do, that's so generic, it's not helpful necessarily, right? I think it would be more a matter of how, in what way could we integrate AI to reduce our cost or to, get to faster insight or to serve our customer better? What are the KPIs of the organization? Maybe start there and see, what tools would actually meet that need. It's a way to show success of adoption at a smaller scale before you can go back and say, now give me $250,000 to buy this magical data set, like Chris said, that will change the world for me. So um, I'm always a fan of starting with what, if it's for free and you can play with it a little bit, try it. My advice would be not to discount the integration pains of any solutions or prototype you can come up with. Somebody who does the IT and the platform and the administration is going to come with that beautiful question like, hey, is this SOC 2 compliant? Does it meet my security requirements? So just as you've seen with any government effort, you need to start thinking about that, I'm going to say equivalent authorization to connect and operate, right? So make sure you consider the full integration and how this would actually be applied after you've cooked up some AI model that would actually, or some application of AI that would benefit your specific unit.
Mark or Chris, do you have any comments on the small team perspective?
Yeah, I think actually like some of the thing that we've kind of all touched on our times, I think kind of at addressing some of the small teams, right? Like some of the what like having an ability of massively synthesized data, right, with good synthetic engines, that possibly for small teams is a great way of rapidly generating data, right? Some of the strategies that I was also showing is, can you squeeze more out of the data that you have, because you only have 3 people that have to model, test, and everything, so you can now like annotate. So I think a lot of these things were directly applicable for small teams. And then the other one that I would not necessarily, and I kind of show a little bit, is like there, particularly now where you're starting to have this model that can generate a lot of data, a lot of images that, yeah, maybe they may not all follow all the laws of physics, but for the most part, they're a good starting point to like warm up a model, right? I'm not saying, right, like the example of pools, right? Like you may not need to have like 10,000 pools to show a model what water is, right? Like to what in general that is, right? And then it's a matter of maybe like try to go and see if I can get 200 pictures of pools so that I distinguish the water in general versus what we find in a pool, right? So I think all of these things are really like size independent of your team, right? Like and I think some of the things that we've touched on today are as I said, like really applicable for small teams.
Yeah, I'd echo that. Daniela said some things along the lines that I strongly believe in, which is like half of our job is trying to make the technology easier to kind of get out of the way of people who actually need to use it. And that's definitely true for us, where we see, so most of our customers have small teams that are using our platform. The challenges in that technology readiness versus adoption readiness scenario. So there, in some organizations, you don't always have the right kind of virtual teams set up to start to work with some of the technologies that are out there, because you're so busy making maps or generating reports or doing things the way that you were doing them yesterday, because that's been what's worked so far, and that's what leaders often are convinced is going to continue to work. So we definitely support small teams in terms of, I'll go back to, we do see a lot of folks experimenting with grants, technology trials, watching things like the OGC projects, and kind of looking for proof points that can kind of convince their teams that actually something that's coming out of the AI market is going to make life faster, or make a project faster, cheaper, or somehow better, achieve those KPIs for your organization better. And I'll go again. It really reminds me strongly of the early geospatial market. It has the potential to be so pervasive, right? Spatial is everywhere, especially in small governments, and in every government, and AI is definitely going to be everywhere. So it will become easier, and there will be more kind of prior art to enable small teams over time. I saw there was a question about Esri. I think, I've worked at Esri. I've worked at Esri competitors before. I think Esri's done a huge service for the geospatial world in general, and sometimes they push things not because they can be immediately applied today, but because they know that tomorrow they will be inevitably applied. And so we need that experimentation from academic organizations like Taylor Geospatial, and certainly like from commercial groups like Esri, just to help push the tech to make it more accessible to all of us, so that we can actually get our jobs done better, easier. So I think small.
Great.
Go ahead.
Yeah, no, this is great. I mean, I'm just like looking at the questions and appreciate the interest. And we have, the clock is ticking. We got only 3 minutes. So I'm going to bundle like 10 questions in one because we have amazing panelists. And my question is then about the future, because we had questions about, you know, quantum computing, whether it's like, is it, you know, all our data will be generated with generative AI? What is the future of data models? What is the rate of, you know, adoption? So, you know, you got maybe a minute each to just tell us what does the future look like and how can we influence it? Maybe I'll start with you, Daniela, Mark, and then Chris.
Sure, way to put me on the spot, Nadine. But I think, you know, I'm gonna keep it succinct. I think the future is bright, as I put in my slides as well. AI is here to stay. It is not something to be feared. I think it is something that is, you know, you have to jump in, but with eyes wide open. I think, unfortunately, sometimes what we tend to do as I'm gonna say, broader community is fear innovation or the mistakes that come from innovation, to the point where we try to regulate it too early. But I do believe there is much yet to still be applied when it comes to AI. I think the biggest shift we're going to see is that bridging of the gap between developing the core technology, but actually bringing it into specific products to market where it can actually make a difference. I'm seeing more and more tools come up like that. It doesn't all have to be about imagery and object detection necessarily. Large language models, contextual generation, data fusion type methods, they're all out there. I think it will start with the customer and the end user saying, what is it that I actually need? And then go find those solutions and find, you know, friends, I'm going to say, and partners in the industry that they can sit down and brainstorm with and say, what is the silver bullet for me? Because it won't be the same for Mark or for Chris, but for what I need, what is it that I should at least start with? So that would be what I see coming.
Sounds great. Mark.
So I'll just say is that, just, you know, understand that AI is in an exponential growth. The number of people that work on it is more than the entire history of humanity worked on AI. Quantum compute, like exponential compute, is happening soon. I would say always prioritize the data, right? Like I'm convinced that models will get democratized if they haven't yet. The data will not, right? You can possibly take a model 5 years old with the relevant data and do much better than a newest model with the wrong data. Always strategize around the data. Make the data priority. And if you can only invest in one thing within AI, I would say invest in the data.
Super. All right, Chris, any closing remarks?
Sure. Yeah, I'll take more of a speculative approach. So one of the things that was really impactful in my career, classic GIS person, was Google Maps. When Google Maps came along, a lot of the GIS community said, yeah, what is this? It's a toy. It's not going to be useful. But it immediately exposed the utility of digital mapping information to managers and executives everywhere. And so that really was a turning point for GIS in that market. I don't think that we've actually seen the Google Maps of AI yet. Some of the stuff from OpenAI and Google and others is interesting, and it has the potential, but we haven't quite seen it get to that level of ease of use and popularity yet. So I'm watching out for that kind of Google Maps of AI experience, and I think that will be a major cultural changer for the AI community and the broader community at large. And definitely thank you all for participating today. This has been great.
Thank you, Chris. Thank you, Mark. Thank you, Daniela. And thank you for the 120 plus, haven't been counting, folks on the line, and all the questions, some of them unanswered. I'm sure they can be answered offline. So I will echo what Daniela said. It's the future is bright and it's a journey. I'm very happy, actually. It was music to my ears because we picked AI as one of our, competency areas and where we should invest in research. So it's great to hear that it's a journey, it's exponential, it touches everything, and we got to find a way to go from the ideas to the research, to the technology, to the customer, to the actual adoption. So thank you again for hosting us. Thank you, Chris. Thank you, Rendered AI, and thank you to the organizers. Really appreciate it.
Thank you so much, Nadine. All right.
Thank
Take
you.
care.
Thanks, everyone.